1, 2, 3. It's working, it's working. It's working well. Good sound. Yeah. Okay. Jnatio, let's go. Yep. Okay, thank you. Okay. Esperamos un... no need. Thank you. Hello, everyone. Let's start this session. I'm going to present today Ebpf and what's possible with Ebpf. My name is Anton Rodriguez. I am a principal software engineer at New Relic. If you don't know New Relic, it's a company doing observability for other companies. So basically, our customers send to us traces, logs, metrics. We ingest them in Kafka, and then we store them in the data in our own database, so they can query that data later, dashboards and alerts and all that fancy things. How many of you are already familiar with Kafka? Can you raise your hand? Okay. For the people who is not already familiar, Kafka is basically like a queue. It's a place where we can write very fast. And indeed, Kafka, it's a writer, so it's because it's really fast writing. And then you can consume later to process the data, but the consumption is not so powerful. It's more oriented to write data. My job in New Relic is Kafka itself and all the teams and services using Kafka, so streaming. I put a lot of focus in make Kafka work for my organization. And the reason for that is because Kafka is critical, we use Kafka at a scale in New Relic, which is pretty huge. Just to give you some numbers, we ingest around 125 petabytes of data per month, and that's growing all the time. I think it's even more visual, 3 billion messages per minute. So just during this talk, we are ingesting a massive amount of messages. In the past, we have just a single Kafka cluster with 275 brokers, and was super painful. Have a so huge Kafka cluster, alerts night, really painful. So like 2 years ago, we started a migration plan to move to the cloud and to, instead of having one huge Kafka cluster, have smaller servers. The thing is, in that process, we learned a lot about Kafka itself, being an observability company, about how to monitor Kafka. And this is the story I want to tell. Some months ago, my company, New Relic, acquired another company called Pixie. And this company was using something called Ebpf under the hood. That was totally new for me. To monitor systems in a totally different way. So how many of you are already familiar with Ebpf? Could you raise your hand? Okay, almost nobody. You are in the right talk. You are going to love it. And those engineers come to me and say, hey, Anton, you are doing a lot of things with Kafka. And we are starting to monitor Kafka using eBPF, right? And the thing is, could you tell us about challenges you have or things you are not solved monitoring Kafka, so we can try to solve those things with eBPF? When I had that conversation, I said, yes, okay, let's do it, why not? But being truly honest with you, I think you are going to waste your time. You are not going to be able to monitor Kafka even using something magical as eBPF and provide that information. It's impossible. And the thing is, I was wrong, totally wrong. They did it. So I'm here today to tell you how they did it and how cool is this new thing, eBPF, and the things you may think are impossible for you with other things, not necessarily with Kafka, which maybe you can monitor now with eBPF. That's the goal of my talk. So, what is eBPF, right? Well, eBPF is a new kernel feature. And if you think in other disruptive technologies as Docker and containers, they also started with new kernel features, right? eBPF, basically what allows us is to tell to the Linux kernel, hey, when something happens, like a program opens a new connection, or a program opens a file, or there is an invocation to a system library, generate an event, and notify me, my service, about that event. So you can know what's happening internally in Linux very, very easily. And has two things which make it very, very different. One is it's the low overhead. Configure eBPF or create eBPF programs to monitor things in the kernel. The overhead is really low. The CPU consumption is really low compared with other ways. Why? Because eBPF program is compiled to bytecode, something similar to Java, even if it's not Java at all, and it's sent to a virtual machine inside the Linux kernel. So we have all those things performance related, like just-in-time compilation and all those optimizations, which makes sure eBPF is going to run in a very performant way. The second thing which is very interesting in eBPF is safety. The Linux kernel is a critical piece of the stack of our applications, so we don't want to break things there, right? We don't want to create any problem in the Linux kernel. And the thing is, with eBPF, we are going to have this program running in the virtual machine. When an event happens, eBPF is going to invoke that program to execute it and to make an operation or to send that information to our application, so we can send it to New Relic or to any other place to take any action. But the thing is, this program running in the virtual machine is going to be validated. So it has a lot of safeguards and a lot of limitations to make sure that program, whatever it does, is not going to break things internally in the kernel. So that makes a lot easier to develop programs and also to upgrade them later, to deploy in different operative systems, makes the whole thing much more easier for all the developers out there. So eBPF, new Linux capability, two main benefits compared with other alternatives, low overhead and safety. Now, okay, how we can start using eBPF to monitor things? The first thing is something called BCC. BCC is a toolkit. It's developed in C, so you need to know C. It's quite easy with this if you know C and eBPF and the Linux, how to work with the Linux kernel. You can create command line programs or more complex things. Just to give you some examples, sorry, it's a bit blurry, the screen, but I'm going to explain them. You can create, for example, a program to measure the disk I/O latency of your services. So this is very interesting for Kafka. It's a typical pain we have when operating with Kafka, and the disk is very slow, and that's generating problems. Or you can create another one to tell you new processes launched in the operative systems, or each time a new TCP connection is open, or any other custom tracing. So with BCC, if you develop in C, you can create all those programs. Oh, thank you. It's much better now, right? Thank you. Now, there is a couple of wrappers in top of BCC, so you can also do some things in Python and Lua, but even with that, it's quite hard for someone who is not hacking in the kernel to use eBPF. And that's the reason for BPF trace. BPF trace is another command line, and basically it's a domain-specific language. That means you don't need to learn all about eBPF, just the specific parameters of this domain-specific language, and with that you can start developing your own applications. And it's super powerful. You can see here with just one line, you can do things like identify the files opened by a process, or how many syscall is doing a program, or how many bytes are reading a process, and so on and so forth. So there is, just with one line in BPF trace, we can do a lot of things, and we can, of course, build more complex programs. Now, another benefit of about eBPF is you can easily use it with Kubernetes, most of the time running on top of Linux. And indeed, there is the kubectl trace, which is using BPF trace under the hood. And the idea of this is I want to see how files opened by a specific service deployed in Kubernetes. You can create this one-liner, and with the kubectl trace, you can deploy it and have access to that information. So even with Kubernetes, you can use eBPF under the hood and take advantage of the Kubernetes standardization layer to obtain all that information. So eBPF and Kubernetes works very well together. Now, this is nice. It's an improvement. It's easier to use than BCC, but we are still in the command line. It's yet hard to operate all those files. So let's see next example. The next example is Ebpf Exporter. This is a project open source by Cloudflare, and the idea here is to use BCC to have like some scrappers using eBPF and sending that information to Prometheus, and from Prometheus to Grafana. So with that, you have those metrics. You now have Grafana. You can have your own dashboards and have some advanced functionality, but the rest still have some limitations. If you want to add new metrics, or you want to monitor a system which is not supported, you still need a lot of knowledge in order to be able to do that. Okay, so it's a pretty cool project, but and can solve a lot of problems. But it still requires a lot of expertise and experience working with those things. So this is where I introduce Pixie, the product those engineers are working on. So Pixie, first of all, it's totally open source. It's part of the Cloud Native Foundation. It's not from any specific vendor, so it's totally open source. I'm not here to sell anything to you. You can use that. You don't have to pay anyone, and because it's part of the foundation, it's going to be open source forever. So that's, I think, in my opinion, super cool. It's using eBPF under the hood, and the thing is, it's something you deploy in Kubernetes as an operator, so you don't have to modify the code of your applications or your deployments or anything like that. It's just you type a command, you deploy it in Kubernetes, and it is going to start to monitor your Kubernetes cluster and all the services on it. And one of the things interesting is it's able to detect if you are running things like Kafka or a web server or MySQL or Postgres or many other things. It's going to be able to detect that and to generate insights or specific metrics for those applications. So today, what we are going to see is how Pixie is able to detect Kafka and generate metrics specifically for Kafka. But it does the same thing for other databases, servers, frameworks, and so on. The list is quite big at the moment, and it's pretty easy to add new ones if you don't have something you are using. Now, how it works. What we do with Pixie is we deploy Pixie in Kubernetes. In every node of our Kubernetes cluster is going to deploy a PEM, what we call a Pixie Edge module, which is under the hood going to subscribe using Ebpf to every pod, every service deployed in Kubernetes, and is going to extract that information and store it internally in every Kubernetes cluster. And then using the UI, we can query that information and create dashboards, create alerts, and do whatever we want, or even exporting it to other places. So this is how it works under the hood. The information is stored internally in Kubernetes. So in your servers, you don't need to export if you don't want the information to a third party, which from the point of view of security could be interesting. It's working using all the Kubernetes standardization. Now, one of the interesting things in Pixie is it's able to detect all the traffic between applications and servers. So in this case, one of the things Pixie is doing is I'm going to subscribe to all the messages, to all the packets which are being sent to Kafka, to a Kafka broker, to a Kafka node. So that Kafka broker running in the JVM is going to access under the hood the Linux API, and Pixie is going to subscribe to an event in the middle of that. You can think in something similar to Wireshark, where you are sniffing the traffic. It's pretty similar to that, but it's working in an upper level. It's not working so close to the network interface. What we're going to do, Pixie, here is I'm going to subscribe to all those network messages. I'm going to filter the Kafka messages, the Kafka protocol messages. So when we are using Kafka, Kafka uses an internal protocol for interchange metadata between the brokers and the clients. So it's not going to read the payload or the other messages you send to Kafka, only this control protocol, and is going to deserialize them, or parsing them, understand what's happening, and with that information generate specific metrics. We are going to see that with a live demo, which is more easier. But first, let me introduce the first problem. So those engineers ask me, what are your problems? And my first problem was the setup to monitor Kafka. Because Kafka, it's quite complex, and to understand what's happening with Kafka, you need to do a lot of things. You normally need to have metrics in the hardware level or operating system level. You need to know what's happening in the Java virtual machine. You need also all the specific Kafka metrics, and those are exported to using something called Gmx. So typically, most of the people deploy something called Gmx Exporter, which is a jar you put in the class path. And this jar is going to take those metrics and make them available for something like typically Prometheus, to have those metrics then available in something like New Relic or Grafana or whatever you use to have access to that. So all this setup is not easy. It requires some time, some automation. In the case of Gmx Exporter, at least what we see in production, the performance hit is quite high. It's easily 10% of CPU, and indeed we migrate from the Gmx Exporter to a Java agent because it's much more efficient for us. So all these things, it's challenging to maintain all that. So my first challenge is, could you help me to monitor Kafka without having to do all those things? And that's what we did, what they did. So, demo time. Sorry, and I don't think you are able to read the comments at all, but let me explain you. This is the setup of the demo. What I did was, first of all, I created a Kubernetes cluster in Google Cloud. I choose Google Cloud because they give me free credits, and that's nice. But you can use AWS or Azure or whatever you want. So first of all, I created a cluster. The second thing is I deployed Pixie in that cluster. So you don't see it, but basically it's px deploy, and that's all I have to do. Px deploy is going to deploy Pixie in the cluster. It's an operator, is going to send all those metrics. After that, what I did was create a namespace in Kubernetes for Kafka and deploy a Kafka operator called Streamsy. Streamsy is an open source project, also part of the Cloud Native Foundation, and the idea is make easy to deploy Kafka in top of Kubernetes. So basically, you do a create kubectl create the operator, and then another command kubectl apply to create the Kafka cluster in Kubernetes, and that's all. And with that, if it works over public Wi-Fi, we should have Kubernetes with Pixie and a Kafka cluster deploy. So now let me introduce Pixie. Once we have Pixie deployed, it's going to start sending metrics. So we can go to work.withpixie.ii and see our metrics here, or you can also host your own UI. Pixie, here we can define the cluster we can see. We can have different scripts, so different scripts allow us to see different things. In this case, Pixie cluster, it's an overview of the Kubernetes cluster, and we want to see the metrics for the last 5 minutes. Okay? And clicking on Run button, we can execute the script. That means we update the metrics for the last 5 minutes. So things we have in Pixie out of the box without do anything, just because I deployed it just before the talk. The first thing is it's able to deploy to identify all the services we have. Sorry about the blurry scheme. I promise you it's much better in my screen. But here you can see all the pods we have deployed in Kubernetes. Basically what I'm doing here, Pixie, is seeing how they connect through HTTP. So it's tracing all those messages and saying between those two pods, there are 1 kilobyte second of messages with this latency, and you can discover all the services deployed in your Kubernetes cluster. Now, oh, this was the browse bot. Okay. Now, I'm not used to use so high resolution for the demo. Now, more things we have with Pixie is going to identify, okay, you are running 2 Kubernetes nodes, sorry, the CPU and the number of pods we have in every node, so we know how much load we have in Kubernetes. It's able to identify all the namespaces, so we have 5 different namespaces with so many pods and accounts. It's able to identify all the services and give us some numbers about the latency. Again, all the pods we have with the CPU, how much they are reading from disk or writing to disk, how many containers they have. One interesting thing is we can go to any of these. Let me choose something. For example, the Pixie. And we can see a specific information for every pod. So in this case, this pod is not using HTTP at all, but we can see the CPU, we can see the container list in case you have more than one, the processes even inside the container. We can see how much traffic it's sending and receiving, the memory in case there is any type of problem, more HTTP, which we are not using. We have even a flame graph for all the pods we have. I think this is pretty cool. So if you are having problems in one of the applications deployed in Kubernetes, and you see it's consuming a lot of CPU, you can go to Pixie, and it's able to generate this flame graph for you in real time and see in what parts of the code you are spending more time. So if you have a bottleneck there, it's pretty easy to identify it with Pixie, at least with a less blurry screen. Okay. Now, so this was the first challenge I have for them, right? And they did it. Deploy Pixie, it's super easy if you are running Kafka in Kubernetes. My second challenge was, or is, identify clients. And the thing is, in New Relic at the moment, we have hundreds of clusters and thousands of different clients, some of them using different technologies, most of them in Java, but there are some of them in Go, some of them in Kotlin, things using Python because they are data science and they have to use Python. It's mandatory for them. So it's not easy for me as someone working more in the cluster side of things, in the server side of things, to know who is using Kafka and for what. You know, sometimes I have to tell them, hey, why you are using this so old version of Java, of that so old version of this Java library? And for me, identify them, it's not an easy task. So that's what first I told them. It's help me to identify all the producers, all the consumers, and all the topics. So it's like the tables in a database. It's a unit logic of information. Let me to see how they are related and what they are doing in general. And this is what they did. So if we go to the beginning of the web page, and I choose a script called Kafka overview, they created this thing, which is, there is nothing here at the moment. So let me launch a Kafka client. We're going to launch here its producer, which in a couple of seconds, if the Wi-Fi works well, should start sending data to my Kafka cluster. Okay, here we go. And now I'm going to launch consumer, which should be reading data from my Kafka cluster. Also, okay, here we go. Seems like it's working. Now we run again, and here we go. We are sending data, and Pixie has been able to identify there is one producer sending data to a topic called Pixie, not very original, right? And reading, we have a consumer task 1, which is an application consuming. And if we click on the arrow, okay, it's even able to give us how many messages and how many kilobytes or kilobytes per second that producer is sending. Of course, this is a hello world example, just one producer, one consumer, one topic, but if you have a very complex topology with many topics, many consumers, many producers, it's able to connect all of them, right? Also for the consumer, we have data. So now Pixie, again, without changing anything in Kafka or using the Kafka metrics, it's able to detect there is a Kafka topic called Pixie with 2 partitions, 1 producer, 1 consumer, and this traffic. We have a Kafka broker path. So this is my Kafka cluster has just only 1 broker, only 1 node, which is receiving this traffic and doing those things. So we can know here how we see how hot we are running our brokers. We are also able to identify all our producers and our consumers, right? And finally, from the perspective of the pods, we can see also how they are related. So we have a pod, my cluster Kafka 0, and those pods, Kafka Consumer 1, Kafka Consumer, Kafka Producer per free, are consuming, producing from them. So this is exactly the information I wanted to have, and specifically this one, how Kafka, how they are working together, right? Okay, now let's go with the next challenge. For me, the next challenge was Kafka Consumer lag. How many of you are familiar with consumer lag as metric? Could you raise your hand? Okay, not too many. Okay, consumer lag is probably the most important metric when working with Kafka. This information, what it's going to tell us is how many messages are in Kafka not being consumed. From an ideal point of view, what we want to do is our consumers read messages from Kafka as soon as possible, because that means less latency, and that means the metrics and the information our customers send to us is going to appear in the database sooner, right? So we don't want data waiting in Kafka. We want the data to be processed as soon as possible. So if we see the data, it's being stored in Kafka for a lot of time or not being consumed, and that means there are problems. Okay, and that's why consumer lag is so important for us, because it's what we typically are looking to identify if we have any type of problem. Maybe the producers are sending too much data, or maybe we have some bottlenecks in our Kafka clusters which are not identified, or maybe our consumers are having problems, like they are rebooting all the time or things like that, and they are not able to consume as fast as they should. So consumer lag, it's a very, very important metric. Normally, it's measured in offsets, and that's the position in Kafka, or we can think of it as the number of remaining messages. The thing is, to have consumer lag, most of the time, from the server's perspective, it's not provided out of the box by Kafka. Most of the people out there have to use some external service to have consumer lag. LinkedIn from Barrow from LinkedIn, it's very popular. Also the Kafka lag exporter for Liven, it's very popular, both of them open source. And one of the interesting things of the Kafka lag exporter is it's able to give consumer lag not only in the number of messages, but in seconds. And this is very useful for us, because if someone tells me, hey, Anton, we have 50 messages remaining to be consumed in Kafka, I don't know if that's a problem. 50 messages, that's a lot, that's not a lot. But if someone tells me, Anton, you have a consumer lag of 30 minutes, I know that's a problem. That means there is 30 minutes of delay in our metrics. It also means at some point we could lose data, because we typically store data in Kafka for a specific period of time. So with consumer lag in seconds, it's much more useful. But even after years working on this, it's still a hard metric to obtain, because you need to do a lot of interpolation and understand how the consumers are behaving in order to be able to calculate this metric. So what I told those engineers is, could you generate this metric, consumer lag, in an easier way? And that's what they did. So let me show to you. So basically, they create a new script, Kafka consumer producer consumer latency. I'm going to choose here the Kafka. And at the moment there is nothing here, right? So what I'm going to do is I'm going to stop my consumer It's going to stop consuming, and that should generate consumer lag because now I have the messages waiting in Kafka. I'm going to launch it again. And here, if we select the topic Pixie, now you can see we have the topic Pixie, one producer, one consumer, and this is the information I want to have. Just 1 second before, the consumer lag for both partitions, we have a spike there because we stop the consumer and the number of messages start to accumulate inside Kafka. Okay, then if I run again, I restarted my consumer and the consumer lag went to 0 because it was starting to read all the messages really fast. Okay. So now we have that information. We can see per partition how is the consumer lag. And typically our engineers will have an alert here. If consumer lag is bigger than 300 seconds, generate an alert, open an incident, and work in what's happening, right? Now, how these Pixie engineers were able to obtain this information, because Burrow and the Ebpf Exporter, they go internally in Kafka to extract that information, but they were able to measure this without anything like that. And I'm not going to go into the code here, but I'm going to show you something which is Kafka Data. So Kafka Data are all the messages in the Kafka protocol between the broker and the applications. So if you're familiar with the Kafka protocol, there are things like fetch, which is Kafka, give me data, or produce, which is Kafka, I send the data to you. Things like heartbeat, which is Kafka, I am alive, continue, let me consume data, or offset commit, which is basically telling Kafka, I finish consuming data in this point. Okay? So all those messages from the Kafka protocol are being parsed and are available in this screen. If we click in any of them, we can even have access to the value of them. I'm not with the screen, I'm not going even to try, but you have all the information sent between the Kafka broker and the clients. So for them to measure consumer lag, again, error. Okay. So for the consumer lag, what they are doing is they are tracking the produced messages, and they have a specific ID every batch of messages, and the fetch messages, which also have an attract ID. What they're doing here is they are doing the difference between the produce and the fetch, and if the fetch is growing, there are more and more difference. That means consumer lag is growing because it's taking more time to read those messages. So for us, for people working with Kafka, was super interesting how, from the external point of view, they are measuring this information, accessing the internal messages. One thing is, I'm not going to show you too much here, but if you click here in the editor, you have access to the code to generate this dashboard. This is kind of similar to Python, but with some specific limitations because of those safeguards we were speaking in Ebpf. So things like a loop, it's something you cannot do in Ebpf because you could do infinite loop and that will break the Linux kernel. But in general, it's pretty easy. And the thing is, here in Pixie, you can change the script directly here in the UI, you can share it later, you can create your own scripts and do whatever you want. So it's super useful. If you have other use cases for Kafka or any other software, you can see here we have a lot of other scripts, GVM, MySQL, etc. You can just take a look to the script, see how they are doing it, and modify the script for your use case. So this is the second challenge. Running out of time, so let me go with the third one. Third one, and this is super painful for many teams using Kafka, is what we call rebalances. Kafka internally works with the concept of partitions, and this is where we send the data. Partitions are the unit of parallelisms in Kafka. So when an application it's reading from Kafka, it's typically reading from one partition, and there is an assignation between that consumer instance, or that instance of our application, and the partition. By default, we cannot have more than one consumer instance reading from one specific partition, right? The thing is, that negotiation to decide what partitions go to what consumer instances is done in real time between the Kafka cluster and the consumer instances. If we add a new consumer instance, in this case consumer instance 3, the cluster and the consumers need to renegotiate again to decide what partitions go to what consumer instances. During that negotiation, Kafka, the consumers stop consuming because they cannot consume and renegotiate at the same time. So they stop consuming, they decide, okay, partition 0 goes to consumer instance 1, partition 1 goes to consumer instance 2, partition 2 goes to consumer instance 3. Now we all agree on that, and now we start consuming again. The thing is, this process is can be very painful because that is going to generate consumer lag in the pipeline. So that happens from time to time, and it's sometimes very hard to know why the rebalances are taking so long. I think this is a very easy example, but thinking applications with 500 instances, 500 partitions, all that negotiation can be quite costly. So my challenge for them was help me to help the teams consuming from Kafka, giving them more information when rebalancing is happening, to identify those things and to have better insight about what's happening. And this is what they did. So back to Pixie, they create a new script called Kafka Consumer Rebalancing. So what I'm going to do now is launch a new consumer. So consumer 2. Here, if we run this, we filter by, I don't remember the name. Here we go. So now we have a group of consumer called test, which have two consumer groups in this moment. And as you can see, there we have a consumer rebalance. So we have consumer rebalance, one member, consumer test 1, and the hash of the container, which stop consuming from 1.4 seconds, and the other one which stop consuming from during 4.4 milliseconds. The reason is because the new one usually takes longer to start consuming. So this is giving us all the information about, one consumer, one rebalance happened, affecting this consumer group, and it took this time. So this is super useful information for the teams to understand how many consumer instances were involved in a particular rebalance. And even here, we can see all the messages in the Kafka protocol, which are sent between the consumers and the producers, the consumers and the brokers, to do all that negotiation. Okay, so if you are interested in how this works under the hood, you can even go here and take a look to those specific messages. I did a talk in the Kafka Summit going into detail on this. If you are interested, it's recorded. So, I think that's all I have. There are no more challenges at the moment for them, but they are looking for new challenges. So if you have any ideas, let me know, or I'm happy to put you in contact with them, or just take a look and see what you can do by yourselves. Summary. Kafka, it's a pretty challenging system, a distributed system for observability. Ebpf, it's something pretty new yet, but it's really disruptive in monitoring, in security, in networking. Those things, the use cases you can do, the things you can do with Ebpf are really awesome. The community is very active. It's growing all the time with new things. So if you are interested in any of those, take a look to Ebpf. Finally, Pixie, open source project in top of Ebpf, which allows you to monitor Kubernetes applications, doesn't require modify your code, redeploy your code, super easy to use, is going to understand some of your services, and the overhead in general is quite low in comparison with other alternatives. With that, I think it's all for this talk. I would love to have your questions and answer them now or later in the hall if you prefer. Thank you. Questions?
How does this work when you add TLS to the mix?
Yeah, question. TLS is kind of tricky. So if you are using TLS, the messages are going to be encrypted. So most of the metrics are going to work anyway, like CPU and so on. But when you want to parse the protocol or the HTTP messages, it's going to be a bit more challenging. I'm not aware of the details. Being honest, I'm not a Pixie engineer, but what they told me they're doing is they are subscribing to events when applications are calling the internal libraries to retrieve the certificates and all that stuff. So they have access to the certificate doing that, and then they use the certificate to decrypt the messages. So it seems like, you know, pretty, I don't know if cool or scary or what, but it seems like it's working, and it's also a good example of how powerful this is. More questions?
Hi. Could you use this solution with other message brokers like RabbitMQ, or is this just tuned up for Kafka?
I think there are other integrations, other scripts for things like RabbitMQ. I never use them. I only work with Kafka, so I don't know how they are compared to Kafka. But for sure, it's perfectly possible to have something similar for RabbitMQ. But I don't know it's exactly the status at the moment. But the easier thing is to ping them in Twitter or ping me. They will tell you exactly what they are. And probably also, if you are interested in specific metrics or have any idea in mind, they can help you to create those initial scripts.
Does this work for things outside of Kubernetes? So, for example, if I have Kafka cluster outside of my Kubernetes?
Yeah, that's a good question too. Pixie only works for Kubernetes at the moment. So it can work with Kubernetes on-prem or in different clouds, but you need Kubernetes. The thing is, because it uses Kubernetes to discover the services, so it lists all the pods and detects what type of service you are running on it. So if you want to use Pixie, you need. If you want to use Ebpf, things like the Ebpf Exporter or some of the tools, you don't need Kubernetes, and you can do that at your own, but you don't have some of these easy-to-use features Pixie provides. I don't know if they have in the roadmap to have something with Pixie in the future out of Kubernetes. Seems like quite complicated.
So I know that the Pixie team has been playing with like runtime security. Oh, thank you. The Pixie team's been playing with runtime security, being able to see sort of like CPU abnormal usage. Is that going to be available straight up in that sort of dashboard?
If I understand the question, it's about security features in Pixie, the roadmap for them.
Yeah.
I know they are working on things like that. Again, I'm a user, not a Pixie engineer. I know they were doing things like identify log4shell and be able to list it in the roadmap. So probably they're doing things in that space. And I think they're going to do more and more. But I'm not aware of anything specific coming. But again, I may be missing things on that because I'm really more a user, more focused in the Kafka thing than in security. But I'm happy to put you in contact with Omid or Ryan, and they can give you all the details.
Yeah, I'll hit them up in their issues and PRs again. It's so cool. Yeah, awesome. Thank you.
Thank you.
So, related to the question about being only possible to use it with Kubernetes, do the consumer and producer applications also need to be running on Kubernetes, or is there some kind of Ebpf exporter that we can, for Pixie, to run on applications where the broker is running on Kubernetes, but the actual consumer and producers are not?
Yeah, good question. The thing is, Pixie at the moment, it's listening in the broker side. So even if your applications are not in Kubernetes, you are going to have access to that, a lot of information. Things like the rebalances, you are going to have access to that information. But you are going to lose some other things, like sometimes you click in the consumer and you can see that frame graph, some specific metrics which are coming directly from the consumer. You are not going to have those ones. But the general overview of what's happening at the Kafka level, that's something you are still going to have because it's listening in the broker side, not in the consumer application side.
So not possible to have all those metrics still with some kind of plugin for the producer and consumers?
What you can do is export the metrics directly from the consumer producer and the metrics from Pixie to the same place, like New Relic, for example, and then you can join those metrics together. But other than that,
not Pixie on a custom.
Yeah, not Pixie. I'm not aware of if you can add external metrics to Pixie. Maybe there is some workaround out there, like have a specific script and then. But if it exists, I don't know it at the moment.
Okay, thanks.
Okay. If there are no more questions, thank you very much. I'm still here in the conference. Feel free to say hello if you have more interest on this. Thank you.
Hello, everyone. My name is Patrycja Węgrzynowicz, and it's very nice to see you here at my talk. I'll be sharing my experience working on highly available and resilient connectivity across three clouds, AWS, GCP, and Azure. Briefly about myself, hola, and that's all what I can speak in Portuguese. And actually, that's the very first time this long time when I speak at live events, so please don't be too harsh in judging me. So briefly about myself, I've been doing professional software development for over 20 years, and my first love was programming. And only almost a year ago, I joined the dark side. I became platform engineer, and I must say that I do enjoy it. I joined for free, and I worked there as senior platform engineer, building their new platform for agenda. What am I gonna talk about today? So first, I would like to explain why at all we need multi-cloud connectivity. Then I'm gonna show you some demo why such connectivity and highly scalable, resilient platform may be useful. I'll be talking around various connectivity options like VPN, like cloud exchange providers, like private connectivity. Then I will move to Kubernetes and CNI, but only a brief overview because Kubernetes networking is such a big topic that I couldn't squeeze into this short talk about so many other things as well. And along the lines, I will show you some performance results of our connectivity and our tests in multi-cloud setup. First, I would like to explain you some context. Form 3, in 2 words, may be called financial cloud. Basically, Form 3 is a company which provides a payment platform for other financial institutions. It makes easier integration of multiple payment schemas. This way, it saves time and money for banks or any other payment processors. What is underneath? There is a pretty complex platform. We are fully cloud-based. At the moment in AWS, we work with microservices written in Java and Go. And we have chosen Terraform as our infrastructure as code tool. What are the challenges of payments processing? First and foremost, reliability and durability. That's the most important. We can't afford to miss any payment. We can't afford to have like a longer outage. Our clients, our customers need like 24/7 processing without any outages. Also, we need to take into account volume of payments which we process, which is still increasing. Plus, on top of this, we need to provide high security because when it comes to money, it's always important to be secure. And think only about some outages last year around cloud providers. Did any of you experience some issues because of one of those outages? Raise of hands, please. Oh my God, it's like half of a room. Yeah, that's a lot. I didn't expect this one, but when I was looking through this list, by the way, prepared by Gmx, so when I looked through this list, I remember that I was hit by number 4. Because besides my regular job, I also teach at Warsaw University. And this was COVID time, so we had like a Discord server just for some consulting or remote teaching, etc. And it was during this consulting hours when this started. We managed to check that we first experienced some slowness, but then it was like totally unavailable. So yeah, so it happens to all of us. So I don't need to convince you that we do need diversity in our platform. That's why in Form 3 we are going multi-cloud. We are working on new payment platform. Obviously, it has all those capabilities like high availability, resilience, scalability, etc., etc. And this time we really need them, because I used to work on some systems that, yes, we were told by clients that how critical their system is, but eventually it never happened to experience any high load or some critical situations. So for us in payments processing, it's important to avoid any outages and to ensure that we can recover from almost any disaster. That's why we decided to go and use, instead of only AWS, to spread our platform to GCP and Azure as well. That was and still is quite a significant challenge, because obviously when you work with one platform, you use cloud-specific solutions, like, for example, AWS SNS queues, S3 buckets, RDS, etc. Here we have to switch to cloud-agnostic technologies that work around many clusters, many clouds. We decided to use as sort of like high-level overview Kubernetes with NATS and CockroachDB. But to make all those tools work, we need first and foremost connectivity, right? Without connectivity, we don't have anything. So that's like a backbone and heart of our platform, to have reliable and fast connectivity. I won't show you very fast connectivity at the moment, because I would like to show you why this connectivity is important and how we can survive any cluster disaster once when we go multi-cloud with a proper set of tools. So for my local demo, I will use only VPNs, but we don't need a very high speed at the moment. Just to show you how it may work. So first of all, my setup, I have 4 clusters available. The first one is in AWS. The second one is also in AWS. The third one is in GCP. And the fourth one is in GCP as well. I had my Azure cluster almost ready, but you know how it happens with live demos. Azure is pretty chimeric, I must say. So let me be on the safe side and use only AWS GCP, but instead 4 clusters. And I based my demo on very cool demo from Isovalent. Isovalent is company behind Cilium. And Cilium is a Cni plugin. Basically, it helps in connectivity and provides some extra feature on top of it, like security, encryption, and that kind of stuff. And one of the most important feature, global services. So basically, Cilium can transform a regular Kubernetes service into global service, which is load balanced across many clusters. But in order to have something like this, first we need to mesh clusters, and prepare kind of cluster mesh with Cilium. So this cluster mesh is up and running already. And the theme in demo is Star Wars. So I slightly modified the original demo by Isovalent. So we have our first cluster. Let me board my X-Wing. Hope it works, and connectivity, yep, it works, and fortunately that's only, unfortunately that's only Wi-Fi, but fortunately it worked. Okay, so we have X-Wing, and we can try to locate Rebel base. So let access service. Yes, we have. It seems that it's Jnatio2022, which is on GCP cluster 3. Let me show you how it's gonna work when we ask many times. I must say that speaking and writing is not my highest skill, but I think I haven't made any mistake. We'll see. Nope, I do. I've forgotten about Carl. Yep, it's here. And now we are good to go. Nope. Yep, done. Yeah, thank you. That was fantastic to have such help from you. Because you know how it is. When you look for it yourself, you never see it. But we see here a lot of clusters. Not so many, only 4 of them, but we see that the service is load balanced, right? So we have Alderan, Jnatio2022, Camino, and Form3. So maybe we'll try and help Form3 to win over the Galaxy, right? Let's scale down other services. So I'm afraid to write at the moment. Oops, actually that was not my goal. I was about to scale it down to 0. Okay, so we should have only now 3 clusters. It seems so, but we need more time to observe. But in the meantime, let me switch to 3rd cluster and let me scale it down as well. So now, oh, it's not scaled down yet. It is now. So now we should have only like 1 and 4. Yeah, it is. So only 2 on the battlefield. And let's switch to the 4 cluster and scale it down as well. Oh, we seen a short blip. It may happen, but we have like still 1 cluster. But we have something like, let me start it once again. Yeah, it always happens with the demos. Let me log in once again, because sometimes there is like a network blip, and with Wi-Fi connectivity, I'm not sure how it works. Oops. let me see. C1 server. You know, I never experienced this one, but there is always first time for everything. So it seems that we have X-Wing up and running. Okay, now it seems fine. I don't want to be so greedy, and I don't want to leave form free ruling the galaxy. I would like to share it with others. It's always better to have more diverse environments. So let me see. At the moment, it's only form free in the galaxy. So let's scale back one of other servers and let's make it running to replicas. It takes a bit of time to start up, but in a moment it should I'm not sure. Oh, I was at the first cluster. See here, I changed my context to C1 again, so it was like no op at the moment. So let's switch here. We are at cluster 2, and now let's scale up our second cluster. The second cluster is AWS again, and we see it, yeah, fortunately. So with a couple of hiccups, we made it. That's good. I hope that you enjoyed the demo. At least you see how Cilium global services work, and usually they work better than it was during the demo. But you know the Murphy law. So that was Star Wars demo. And now we can move to how actually we can work toward making it real-life experience. So when it comes to requirements, I'm not sure, but it's always to be fast, right? It must be fast for connectivity. For reals, I'm not sure. Maybe in the sense that this connectivity should meet all our sometimes insanely high requirements for our platform, and it should provide us self-landing. So we need to be secure, and we need to know that our solution is feasible. And when it comes to real-life requirements, obviously low latency. We want to cluster across many Kubernetes instances. So it means that we need to replicate some services like for some data like for NATs or for jet streams, and for some of those services we must provide synchronous writes. So that's important. We need to have a steady bandwidth. We need to know what we stand on, right? Plus, with payments, as I told you, security and privacy is always an issue. Also, we need to provide high availability setup and fault tolerance in case of failure on any level. So being it a link, a device, a point of presence, etc. So we came up with 3 options. Virtual private network, This one is pretty easy to set up because that's like an encrypted tunnel over public internet, and all major cloud providers, they offer similar services, usually with high availability setup. Another option we thought about and we were very close to choosing was direct connectivity via cloud exchange provider. So there is some companies that allow you to buy basically a connection, rent a router or something like that. So basically that's a network as a service. And we could buy like direct connectivity and route it via virtual router to another cloud. And such an example is for is Megapod, is such company we tested and we almost used. But eventually we decided to go with direct connectivity via data center. That's a very similar setup like with using cloud exchange provider. But instead of virtual router, we have a physical router in a physical data center we operate. So let's go through some pros and cons for those solutions. So when it comes to virtual private network, as I told you, it's really easy to set up. I told you that at Form 3 we use infrastructure as code almost as a religion. So that was very important for us to, that a solution guarantees such terraforming. In virtual private web network, we don't have any third-party dependency. That's always good. It's always a problem when you need to deal with many vendors, right? So that was our pros, but we ended with a very long list of cons. First of all, higher and unpredictable latency. Obviously, this connection goes through public internet. You never know what you'll see in World Wide Web, or maybe World Wild Web. So it depends on situation. Routing may go other way, other path, and we end up with some spikes in our latency. So with routing, there is another, with unpredictable routing, there is another problem. When it comes to sensitive data, there is some regulatory requirements sometimes that they can't leave some zone, a country or something like that. So for example, for a GPRD privacy issue, your data can't go for example, outside European Union. And with public internet, you never know how your packets are gonna be routed. On top of this, we have like unpredictable bandwidth as well. Again, the same case as latency and routing. And basically as our primary solution, it was never an option. We considered VPN as like our secondary backup option. And with such assumptions, another con was that it would be more difficult to configure automated failover combined with other solutions. So we did quite an extensive and deep research around cloud exchange provider, but it's like a very shady area. You never know what they have underneath the API, or if they ever have an API. Sometimes it's like only a shady web page, so that was a no-go for us as well. That's why we took a deeper look at Megaport, because it provides a Terraform provider. So we tested with our Terraform solution, and it worked. And it worked pretty well. However, we experienced some problems. The problem was we were investigating high availability setup with Megaport connection and Megaport virtual router. And that was a problem at the time for us because we were interested in London region. Our platform is going to be based in London region, so we needed 2 points of presence and 2 routes to every cloud in London. And unfortunately, at the time, Megaport didn't provide it. Their backup route to GCP, as far as I know, was going to Frankfurt. So that was like, again, a very long latency. We couldn't afford it even as a backup. So that was no-go. Another no-go was that as company involved in the finance world, we sometimes need some clearance, contractual agreements, that kind of things. And with Megaport, it was difficult to get them audited. It seems they were not interested in security audits of any kind. And that was like contractual obligation for us. They didn't offer any special enterprise class support for us. Again, when something's happen, we need to have like a support to go to, and the support needs to work 24/7 the way our platform does. So that was no go. We explored an option of direct connectivity via data center. We are more like a software company and involved in virtual cloud world, so we don't deal with hardware on daily basis. But we have like a very good partner. A host operator and data center operator, which takes care of our hardware for us. So that was a plus because we had someone to talk through our possible solutions and directions, and we had someone to trust through. Plus, with direct connectivity, one more drawback of Megaport was that, as I told you, for some regions we didn't have like 2 different routes available to some cloud provider. Here with direct connectivity, we are more flexible because we can go to another provider and we can have some connections from one and others from another provider. So that's more flexible. Obviously, we have good predictable latency with bandwidth and secure private connectivity. Unfortunately for us, we have a problem because infrastructure as code is not possible, fully possible at least, because our routers, hardware routers, physical routers are managed by our partner, our vendor, and they don't do Terraform. So, plus with some hosted connections or hosted virtual interfaces, in both cases you have problems with monitoring and observability. So that's a problem. But on the other hand, we don't have problems with clearance, security clearance. That's very important for us. So that was our way to go, direct connectivity via data center. And I must tell you that we succeeded. And actually, it was a couple of months ago, we managed to make it working. However, it took like 2 or 3 months to set up all the things, especially those discussions with our vendor were time-consuming and quite exhausting. On the other hand, it works very fast. We don't observe any blips, which we observed on one megaport link. So again, that looks much better, and we have predictable latency. I will show you some tests later on when you have like some connection anomaly with some solutions, and we don't want this one. So on very, very high level, we have like redundancy to, we have 2 data centers, we have redundant connections to every cloud, we have redundancy and HA setup for direct connect, interconnect, or express route. So that looks pretty neat. When it comes to more detailed diagrams, it differs per cloud. If you are familiar with a couple of clouds, you know that their naming, their wording is different, their concepts are a little bit different, even though underneath, in case of connectivity, it boils down to, usually it boils down to some sort of a router with BGP and dynamic advertising. I think that AWS is the one which has a lot of those individual elements you need to connect in order to establish connectivity. Obviously, we use transit gateway. We have VPC attached to this transit gateway. Then, on the other hand, we have direct connect gateway, which routes to 4 virtual interfaces. We have redundant interfaces, 2 redundant interfaces per connection, and those goes to different data centers. We have some naming around clouds as well. You see that in terms of elements being used, GCP is definitely the winner. And it was really very smooth configuration. On the other hand, Azure was, I was going to say our pain in the ass, but maybe I should say like the most challenging one. So with those long provisioning times, different broken peerings that happened till this time, and basically that's the beauty of Azure. Plus, unfortunately, we had to change our BGP configuration on our data center routers for Azure because Azure doesn't support custom CIDR advertisement, so you can't set up custom CIDR to be advertised over BGP. It only advertises connected virtual network CIDRs. And that was a problem for us because we had like one big CIDR range set up on Azure side, and our routing in DC was configured to do exact matching. So it didn't work this way. We had to change it to or longer, so just to have more flexibility. Okay, let's move to some performance tests. The performance test we did with free tools, and actually there is a very neat setup on GitHub with Kate's NetPerf. It includes free tools, Iperf, NetPerf, and Fortio. And Iperf was used to assess throughput, as well as like to detect some blips or issues with connectivity. It provides quite good tooling. NetPerf, on the other hand, has a very good set of various metrics and various tests. We focus on TCP RR and TCP CRR tests. RR stands for request response, and CRR connect request response. So basically, TCP/RR is for use cases when you have a long-lived connection and you do many requests over this one connection. CRR is for cases when you have like make a connection per request, basically. So this also happens sometimes, but less common. And for Forgio, we want to have some more higher level results for different HTTP protocols. Maybe HTTP 1.0 is like a historical one at the moment, but for like awareness, custom awareness, it was good to learn how big is the difference between HTTP 1.0 and the next versions. 1.1 is, I think, the most common one. However, we are switching to HTTP 2.0. We as a world, there is this common switch to HTTP 2.0 or higher, and gRPC uses by default HTTP 2. So here, in this case, again, what was interesting, latency and throughput. Let us see some results for VPN, multi-cloud connectivity, and in two modes, node-to-node and pod-to-pod. Node-to-node is basically your baseline. When you have like Kubernetes on top of it with its custom networking, it's like an extra layer of abstraction, and when it comes to any performance problem, they say that you can solve any performance problem by removing this extra layer of abstraction. So fortunately, it looks like in this setup we don't have any particular difference in node-to-node and pod-to-pod results. It's almost the same. Those graphs looks very similar, and you always have some like small differences. That's like normal. When it comes to VPN and DC, here you have like AWS GCP with VPN, and just right on the right you have AWS GCP with DC connectivity. So here you see a huge difference, maybe not in P50 or P90, but P99 it's like half of that on VPN. That's again what I was talking about, the result of this unpredictability of VPN. And we can see here that GCP basically has some problems with networking in London region. With GCP, we always get highest results. We see those one in VPN. DC private connectivity is much, much better. Again, I think that's like 30% more speed and less latency in case of DC, but still comparing to other pairs like AWS Azure and AWS GCP, those are better. And here you see like an anomaly. I had to rescale this diagram because that's the result of one of our tests when VPN was like between GCP Azure skyrocketed basically. It was on average it was around 50 millisecond. That's a lot, and that's like not acceptable in case of clustering of any kind. In case of latency latency latency
latency, we focus on pod-to-pod connectivity at the moment because that's our target one. As I told you, we don't observe much difference between node-to-node baseline connectivity and pod-to-pod on this one. One more important thing, all those tests were done with, till that time, were done with original CNI, Cloud CNI specific plugin. So no extra plugin here, only the original cloud setup, and it performs very well. So if you don't have any specific needs, you don't need to use any other CNI plugins. You are good to go with what clouds have to offer. But let's move to Kubernetes and CNI just to go over very, very briefly on very high level about Kubernetes networking, just for you to realize that nothing's for free. So we have very good baseline connectivity, but on top of this, we have many protocols, and each one of them and each tool adds extra performance overhead. And Kubernetes with its custom networking is very specific because Kubernetes have very specific requirements on how containers must behave in terms of networking. They need, each pod needs to have its own IP. This own IP must be visible to other pods, must be routable, and the pod itself must see this IP as its own. And basically, that's the responsibility of container network interface plugin to take care of IP assignments and take care of routing from one pod to another. And think about this one, that's not that simple because it needs to go from one, in many cases, it needs to go from one node through host network to another node. So each cloud provides its own cloud-specific plugin. With clouds, you don't have access to configure your network as you wish. You need to adjust to cloud-specific security requirements and basically just not to mess up with routing and networking for all the cloud. That's why we have such limitations. We have those cloud-native plugins which perform really well. I was really surprised because what I was told before is that you need to go with, for example, Cilium. Because Cilium supports Ebpf. That's like sandbox code on kernel level, and they do routing that way. So it must be faster. It turned out it's not that faster, or it's not at all. We didn't see any difference in performance. Why? Because again, Cilium in clouds has very limited configuration options. And for example, we can't configure Ebpf host routing. We need to use legacy mode because basically clouds don't allow on such routing modes for CNI plugins. When it comes to CNI plugins, we have generic ones which can be used in clouds or on your bare metal machine, Kubernetes. There is a couple of them. I think that the most popular one is Calico. we are in the process of testing Calico, so we don't have performance results for Calico yet, but we are focusing on Cilium because Cilium was used by one of our teams and they were pretty happy with Cilium configuration. They had they needed to use custom plugin because they have clusters in data center and they have clusters in cloud. So in data center, basically you need to configure some custom plugin because otherwise it won't work. Networking won't work. So Cilium is pretty interesting when it comes to features. It's very rich in features. However, it's very difficult to configure. We have many knobs and puzzles around configurations. Basically, the most interesting features of Cilium is Cilium cluster mesh with global services. You've seen during demo one example of such global service. So basically, it's like one service across balanced across many clusters. A small problem, or actually in production usage, it might be a big problem, is that at the moment Cilium supports only round-robin policy with load balancing. So for example, if you invoke a service from cluster, you can end up with another one. There is no affinity towards a local cluster and local service. So in terms of performance, it might be a performance kill in some cases. So that's not best, but they told us they are working on new features. Finger crossed, they are gonna be released very soon and they're gonna be in a good shape. Another important feature for us, it was network policies. Cilium supports identity-based network policies, so we don't need to focus on IPs. We can assign like more logical names, identities to our services or other elements, and we can organize our security rules around those identities. So it's much smoother and it's easier to manage. So that's important. Plus they provide some network policies in L7 layer, which is also very important for us. On the other hand, one thing they were famous of, encryption, it didn't work for us very well because our pen testers, that's pretty good team, they discovered that Cilium doesn't encrypt traffic inside one node. So when two pods are on one node, this traffic between those two pods won't be encrypted. And again, that's a no-go for us because our goal was to use Cilium encryption as encryption in transit, and we can't use it that way because there is like a moment when data are not encrypted, and that's not a good solution in terms of financial services. Another thing they try to go with is pod IP routing, that they provide pod-to-pod connectivity. However, in terms of clouds, with cloud-specific CNIs, you get this for free. At least with Azure, AWS, CNI, the tests you've seen, they were like pod-to-pod tests without any extra CNI, and this direct routing just works. With Azure, there is one problem because we need to configure Azure CNI instead of default kubenet. So there are some neat use cases, but let's move to latency and Cilium versus cloud-native routing. When you take a look at those figures, they are very similar. Again, AWS, GCP with Cilium and cloud-native CNI, they look almost the same, and that's the case for other. So on one hand, that's good for cloud-specific CNIs, and we see that with cloud limitations, Cilium doesn't shy as with bare metal machines and custom Kubernetes installations. So that was like very quick go through our journey to multi-cloud connectivity. As you can imagine, there were a lot of traps on this way, but we managed to go through them in one piece. So we are happy. But on the other hand, we've learned a lot. And we've learned a lot that we need to use our tools wisely, because a fool with a tool is only a fool. And we need to know our tools, and that's my piece of advice to you. Know your tools better, test, 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 and make your decisions based on tests and data. That's very important to understand what's going on in our IT systems. So thank you. We are running out of time, but I'd be happy to answer any of your questions during break time. And tell me about your journey, whether or not you are interested in going multi-cloud. Thank you.
We're live? Perfect, perfect, thank you. So, can someone close the door? I have a nice stream deck now, it's really nice with all kind of nice recordings. Let's wait 1 minute more, because still people some joining, so welcome everyone. Come in. Welcome everyone. I wait till the door is closed and then we're ready to rock and roll. Still some seats up front if you want, or there. So it's scary, I know, but I'm sweet. I hope for you. Excellent. More people, better. Still some seats if you want to sit. It's still possible up front here. Yeah? Cool, cool, cool. Okay, let's go. First of all, can I have an applause for the people behind the scenes? You don't hear them, but really doing an amazing job. So thank you for that, it's really nice. Hi, my name is Koturk, and today I present to you event streaming application with Kafka Stream, Spring Kafka, and Actuator. So let's go. What do you learn today? You will learn how to produce and consume messages with some Spring Love. Spring Love. Yeah, this is the fireworks. And it's Spring Kafka. And we will use a Spring, we will create a Spring Boot application later on. So there will be live coding, so please hang on. We will also create some process some big data with Kafka Streams. So we are plugging a lot of messages, big data, and in a streaming way we are processing those messages. And the most important thing is the actuator. A lot of developers are forgetting this, especially in a big data environment. You need to have something like an actuator. You create logging, right? Who's creating logging nowadays? Nobody creating logging? A raise of hands. Metrics, who's creating metrics? Perfect, perfect is even better. But still a lot of people are, where is it? My screen is gone. Oh, that's strange, okay. So, yeah, we need to have proper monitoring, and we'll do it like here. So you can see your dashboarding tool that you are going to process message, for example, but I'll show you just in a minute. So a big warning, this meeting will contain some live coding, so everything could potentially go wrong. So yeah, that's possible, so I hope not, but so the story. It was a rainy day in the 90s. And it was horrible for us developers to talk to other systems. It was really a disaster because, yeah, I will close it now. It was really a pity because, yeah, if you need to communicate to other computers, that was really difficult. They need to program the whole stack themselves. So they had nothing with REST or something. They didn't have something with SOAP or even not Kafka, right? And yeah, that was a horrible time to be a developer that day, or it's more like cowboy, I don't know. But back then, in the 90s, later on, you have Corba. Who is using Corba nowadays? Perfect, thank you. So it's like a haunted house nowadays, and it's removed in the JDK 11. And yeah, it's sending, you can send messages to a broker, and the broker will send it to the other side. You have an interface in the middle, and there was something. So developers were really happy about it, but yeah, you can imagine it was slow because you have network latency, and if you need to change a contract in the middle, then yeah, you need both parties. In a big organization, it's horrible. So a haunted house. And then we had the Solar Eclipse in the Netherlands, and they invented SOAP, and SOAP was much better, right? Who's using SOAP nowadays? Still some people, okay. And SOAP was pretty nice because it was XML, right? And we can understand it, everybody can understand it, so, but still the bandwidth was really large. Yeah, you know, XML can be pretty big, so that was also not a kind of solution. So they invented something like REST. Who's using REST nowadays? Yeah, thank you. So yeah, that's really nice because you can send messages through JSON, and we can all. It's not complex, it's easy, and we all understand it. So pretty good. Yeah, it's invented by Rolf Fielding in the zeros, and now we're using it all. But sometimes it can be a little slow. So like, for example, yeah, we want to have big data and it needs to be very quick, right? So let's go asynchronous with Apache Kafka. Event streaming application with Kafka Stream, Spring Kafka and Actuator. Hi, my name is Kouturk. I'm coming from the Netherlands. I love the jugs, all the jugs. I'm talking about Kafka and Micrometer. So that's why I've also talking about the Actuator. Please follow me on Twitter, it would be nice. So yeah, who's already using Kafka? Perfect, nice. A lot of people already using it. So yeah, in this session I will create some basic application with Kafka, a consumer and producer, and I will also tell you something about Streams API. But first, why? Why do we need something like event streaming? There are three here. So it's like on a certain time there can be something horrible can happen on 12 o'clock, and it can be time-based. So that's like a Linux cron tab. So the first one, and the second one is HTTP, like you're going to the museum, you go and watch a painting, and then you're done, and you're going to the next one, and you're going to look, and you're going to the next one. And with events, it's totally different. They're all spider scrolling everywhere, and yeah, you need to do something with it, and it can be one, but it can be also billions, and yeah, you need to process that, right? That's why Apache Kafka. So we need something fast. We need something less complex. So we need something what is functional also. So we have functional programming, that would be nice. Something fault tolerant. Like if it's burning, it needs to fail fast, and yeah, you need to be fault tolerant. We want to have replayability. Like if something happens, it needs to continue. Maybe you need to change something in your application, but yeah, we want to have the replayability. And for that, we have Apache Kafka. Can I have applause, please, for Kafka? Thank you. Yeah, some people already know what Apache Kafka is, so I will be very quickly. Yeah, you have a producer and consumer mechanism where we can send messages. So it has all kind of libraries, Python, .NET. You can use it for every. And we will save its messages based on the retention time. It works with sequences that it's remembered where it was. So if there's an exception, you can go back in time. So why is it fast? I had a last question last time. And sorry about that. I'm talking too much. And yeah, you have a lot of network calls, and what they do with Kafka is they bunching it together, so it's quicker. So they do all kind of batching inside. And they have also something like avoids seeking time. So they only adding something to the log. And it's not searching, so you have sequential I/O. And you have something like the zero copy principle. Oh, sorry. But why not using RabbitMQ? Yeah, that's the question. If you want, it's more like fire and forget RabbitMQ, right? And with Kafka, it's knowing like, hey, if I have a payment, I'm working at a big bank, and transactions are important, right? You have a payment, and you don't want that to be lost. And there are possibilities with RabbitMQ, of course, but mostly you're paying also. But within Kafka, you have the option to replay it. So if something is burning, you can just replay it and you have save it somewhere. And that's really nice of it. And it works with consumers and RabbitMQ with queues. And yeah. There are 3 flavors. We can move data from another source to another source through a topic. So through connectors, you can build your own connector, or you have a GDBC connector and you can stream everything to a database if you want. But we are not talking about that one. We are going to, some animations. And we are going first build a simple REST application. It will be a basic, and what it does is the following. It's going to write to a topic. So we are going to produce a message. And we're going to consume it. So that's the first part I will live coding. We have also something with big data. So you can imagine that you have a topic with a lot of data in it. Everyone is pushing to that topic because it's coming from all kind of systems. It can be automated. So the topic can be pretty big. It can be millions, billions even. So for that, you don't want to use a simple produce a consumer functionality, but we're using the Streams API. What we are going to do is the following. We're going to write something new topic and pick it up with a streaming application. And then we're going to send to another topic. So what we are going to do, we are going to check the balance. And if the balance is okay, we're going to the next step. And those can be separate applications. Because on a big organization, it could be that someone else is maintaining the application, right? So you have a fraud desk, you have someone for the payments, for the balances. So they can run separately. So that's pretty awesome. So let's eat some code. So what I created on the left is a project explorer. You don't need to see it. Is having a controller. And the only thing we are going to create now is a produce and a consumer. So this one, we're going to create, push a message to a topic and consume it. So, and if you have questions, please let me know. So for that we have a POM. I'm using Maven. Who's using Maven nowadays? Is using also Gradle? I'm very sorry, I'm using Maven now. But it's the same drill, right? And the only thing what you need to use is the Spring Boot actuator, like creating metrics. And for creating a produce and a consumer, we will use the Spring Kafka library. And is someone using Quarkus already? Okay, there's also a library for micrometer for Quarkus, so you can also use it there. And probably not Spring Kafka, but yeah. So what we are going to do is we have a POM. And in that POM, we have also something like a build. And Apache Kafka is working with Avro messages. So you're sending, instead of XML, we are sending Avro. And just like XML is SOAP, you can also marshal it to an object. We did it here, and we have one object called, where is it? is in the resources, we have a payment. So what we are going to do, we are going to create a payment. So this is the Avro. I'm using live templates, by the way, in IntelliJ. And it's perfect for this kind of demo purposes. And I created a payment with a name, an IBAN, to IBAN, and an amount. So I created an Avro message. I'm also going to start my own Docker. So it will be all on GitHub, so you can already look to it at my GitHub. I will share it later on. And you will find everything there and a different branch, the solution. So I have something like Docker. So what I'm going to do is I am going to start some Docker images like Kafka. And I have some GUI, and I don't want to talk a lot about it. This is a different topic. And I'm going to start it. So the only thing that I do, you can do it also at home if you want, or we're just starting it up if you have Docker, of course. So it's spinning up some Kafka locally. Of course, we have cloud vendors, right? You can use something like a Confluent, right, or an Actual or whatever. And I'm just using the local one. So I already created some topics. And I have also something like a Kafka GUI, and I already created some topics here. So I created a payments and fraud topic. So the next thing is that we're going to do is we're going to produce some messages. So we have a payment controller here, and that payment, and the payment controller is going to create a payment. Yeah, it's just create a payment. Like this one, it's creating a payment and we want to send it to a producer. So we are going to, inside the process payment, sorry, I'm going too fast maybe. There's something here that is processing the payment and we're going to go there. And the only thing you need to remember now for Spring Kafka is you only need an annotation. It's very simple, so the only thing we do is like, we have a Kafka template. So that Kafka template, you can do a send on it. So like here, we have the Kafka template and we want to send it. So we have a send transaction here. If I'm going too fast, let me know. And what we want to do is send a message with the Kafka template. So what we did here is a send message. So the Kafka template sent, and the only thing you need to do is the topic and the message. So that's pretty easy for a straightforward application to send something from a REST application. Yeah, we can also consume something, right? So it's also possible to consume something. So again, the only thing you need to remember is we have an annotation for that. It's all Spring magic. It's not always good, but in this case it's good. And with this, we already get some free metrics from Actuator. So when I start the application, you will see I already got some metrics for free. Like, are there any messages on the topic, the lag, and that kind of things. So that's pretty easy. The only thing you need to do is to consume it. And you can save it, right? Like here, a cast to a payment. So in this moment, we send something to a topic and we consume it. And I want to approve it with a JUnit test, a Spring Boot test. So I have an embedded Kafka test. And yeah, just run it. Did I forget something? No. Doing some weird stuff here. Another time. It's also with Kafka, it's also the downside is like if you're running locally your Kafka instance, it can be difficult because you need to think about petitions and that kind of things. And you better go to a cloud vendor, then you don't have that hassle. So in this moment, we send some message to a topic and received it. So what I did here is again just call this method that is processing the message. and then later on I'm going to get the payment. So that's pretty cool. The next step is maybe some exceptions can occur, right? And we want to have a metric for that. So I'm going back to the service, and I will create something like an exception. No. I'm going to, no. It's nice, but... So I'm now going to filter. So before sending a message, I'm going to filter on IBAN. So maybe someone is trying to hack us or something, and we want to check the IBAN or something. I don't know. All things are possible, and we have an evil IBAN. And yeah, we want to send an exception then. So we have something like a filter exception, and we call it up, and new filter exception, and something like, oh no. And we can, at the end, just throw up. That's a funny joke, right? Throw up? No? Sorry, it's pretty bad. And yeah, what we can do is now just start the application. I'm just starting it here, this may be handier. Just start. Oh, it's already started somewhere. Just start it again. And we are going in IntelliJ. It's also possible to create a call to your REST endpoint. Normally, people use Postman, right? But you can also do it in IntelliJ. So that's something I learned also. And you only create something like just do a new, and then you say HTTP. And you say HTTP request, and tada, you're there. You don't need Postman or something. And what we are going to do is post something. We post something to the metric, and we get an internal server error. Of course, you have error handling, exception handling, but you also want to see it in your metrics. So what again saying, sorry about the hassling, we have also something like metrics. And we have an exception. I called an exception here. So I created something what looks like a metric. And we can just do it like this. So at this moment, we have also an exception. So you can use it for your dashboard or something. So yeah, it can happening that you have a long list of exceptions, and your manager is calling, yeah, there's something happening with your code, and you don't know where. But if you just create a metric of your exception, then you can see it, and then you can also see the priority. Like if 100,000 times you have an oh no exception, you know something's happened. So you already know it up front, the people are calling you. So that is pretty good to remember. And also tomorrow, if you're not using it, start using it, I hope. So that's that. So we created something like producer and a consumer. And now the next step is we're going to create, and we'll close this all, sorry, and we'll create the basic. And the next step is, oh, by the way, that's the HTTP server request. It's also a dashboard. You can also create a dashboard in Grafana of it. It shows you all things like it's an exception occurred. So now back to the big data part. So what we are going to do, we have a topic, everyone is producing to that topic, and we need to pick up all those data in a streaming application. So in a functional, not complex application. So what we are going to do is we create a payment topology. So in Kafka, first we are going to the POM, because we're using something like Kafka streams. And later on, I will also create a test, or already created. You can also create your test inside your IntelliJ, so you don't have to spin up a whole cluster if you want. You have just a driver that takes care of that, or something like test containers is also possible. And yeah, maybe I can show you now with something like super fast. I can also create topics here and a test driver. So the first thing, we are going to create a payment stream where we are going to check the balances. So the first thing we need to do is something like create a stream of payments. So the only thing is the builder.stream and then your topic, and then you get the messages from that topic. And what we also want is create some metrics maybe. We have the counter again with the actuator, and you can also count. This is very important. Mostly you have logging, but again, you have also something like actuator, and you need to have a builder and a message count. And you can also give it a tag. We are giving a tag with bankcode and with IBAN. So if it's a Rabobank or is it ING. And yeah, we are going to create the metrics I already did. And we are going to check the balances. So the next step is we are going to filter. We filter on balance. Is the balance all right? So we just do a payment get balance, and it needs to be more than amount or equal. And the next step is we also want to send it to check the frauds, right? If it's filter and the balance is okay, we want to do a fraud check, and that will be a different application. And yeah, we are going to create another object called a fraud object, and we can peek it again. With peek, it's just a logging or something, and we are going to send it to a topic with 2. And what I want to show you, you can also make it visible, because I'm now telling you through code, but you can also make it visible. So in some seconds. So we now created a stream, but I can also make it visual for you, so you can see. Like there's a pretty nice URL, Kafka Streams Visualizer, and you can visualize what you're doing. So again, I'm going to build a topology and visualize. So we have a topology description. And I'm going to start this application. So it should be a description. Where is it? Description, like here. And I can copy it. And I have a website where you can just make it visual also. And that's called this one. And it shows you what it's actually doing. It's not so, it's maybe, so it's better, right? So we have a payment topic, and we're getting the source from it, and later on we pick it. So we do something with it, like logging, creating a metric. We are filtering it. Is the balance okay? Then we map it to a fraud. So the next step will be a fraud check. And we pick it again with logging or metrics, what you want. And then we sync it to the fraud topic. So we also make it visual now, so you understand what I'm meaning. What is nice of Kafka is that you can also have an application somewhere else, and it's also reading to Kafka, and it's a different department, and those are checking the frauds. And now we're going to check the frauds. So we already consumed something, or produced something, with the payment stream, right? And the next step is the fraud. So what we want to do is create a stream. And a stream of frauds. Possible frauds, we don't know yet. And again, we are going to peek it. Yeah, I'm doing a lot of peek because that's handy with logging. If you have some exceptions and yeah, the customer or some people are calling you, hey, something happening, then you can somehow trace it. Not with system out print line, don't do this, but just do it with log debug or something, right? Or log info, or yeah, you know what I'm meaning. And the next step is we are going to filter. And we're going to filter an IBAN. And again, we can, it's giving you an exception, like a filter exception. And again, we are creating a metric of it. So we're catching it here because it's a catched exception, because it can throw a filter exception or something. And we do that all here. If it equals this one, I will send some big data tests later on to this application to show you that it can process a lot of messages. And if it equals Deutsche Bank, yeah, or something evil, what you want, just example. And yeah, you can throw a null pointer, but then you need to have some exception handling. That's difficult. But you can have also exceptions like a filter exception, right? So this is another joke. I made a Java program to tell me my purpose. It keeps saying null point exception, so it works great. So again, a funny joke. Sorry. And filter exception. Yeah. We are going to filter an exception. So if something happening, you want to again have it visual in your dashboard with Actuate, of course. And we're going again to map it. And in a moment, I will show you. I peek it, and maybe I can delete it next time, but it's just to show you. But who's ever played blackjack here? Nobody? You have a kind of split possibility. Like I want to split it and I want to go further with 2 streams. That's also possible with streams. So what you can do is split it. And the only thing you need to do is split. Dot split, of course. And then, sorry for this one. So, and the next thing is you can have a branch. Like we have 5.7, you have a branch. And I'll show you in a minute, we have a reward. So this reward is false. So this branch is always false. So yeah, you can think of something beautiful, some logic where you can say, hey, when it's a good customer and with 100 transactions a year or a month or something, I don't know. But that's possible. So you can make your own thing there. But now it's false, and it will be redirected to a default branch. And the default branch is now the blacklist. So we now send it to the blacklist topic. And again, we return the stream. So we have a fraud stream here. And yeah, let's start it again. And let's do some test. I want to have topology and debug. And again, to visualize it, we have something made like a description, right? It's somewhere here. We should automate it somehow. Dus we have something here, and we copy it. And again, I try to put it here. And it's updating. And this we already see, right? It's going to send and peek to a fraud topic. And the next step is, from that one, we are also picking it up. We're peeking, we're logging, creating metrics, and we're going to filter it. If it's an exception or not, you can filter it, map the values, peek it, and here's also something what's happening, like you can branch it in 2. So one is going to the analytics or rewards, and the other one is just going to the blacklist, possibly a fraud. So we split it here. So I'm going to show you also something. Yeah, the actuator, because I'm going to send some big data tests I created. It's sending 1,000 messages now. Of course, you can have billions, right? But it's just a big data test. And what I do here is I'm sending a lot of data here. It's a for loop. Sorry. And it's sending 1,000 messages. So I have a Kafka UI here, and it shows you something like the topics. Should be. Another time. So I have a lot of messages now in payments. And I have some blacklisted files. Some were from Deutsche Bank, the filter which we did. So that were possibly frauds. Or something happened with that bank, that's also possible, right? Or it's just an example again. nothing against them. And it's sending to a blacklist. So we have 755 messages in another topic, and a fraud topic we have 1,000, and the payments 1,000. So the next time I can also send it, it will begin from the sequence 1003. So it's going to redirect it, or you can set your sequence back, but that's another story. And 0 at our rewards because the case was false. Sorry about the switching all the time. And what's I need to show? We have also application YAML where we expose all the endpoints. Yeah, think about it, what you're exposing, right? And we're going to export it and serve post. Okay. What you also can do, what I said, you can also run it in memory. So the whole test we did, we can also just do it locally, instead of having a whole bunch of petitions running Kafka on it. So what we are going to do now is just run this one. And you will see it's just done within milliseconds even. So this one is in IntelliJ, and it's you don't have to hassle about things Kafka related. It's just sending something with a test driver. Again, this is a lot of code, but you can find it on my GitHub. There's some README also. So yeah, you're creating a topic and fraud topic. So pretty nice. Yeah, what I show you is that you also need to think about metrics. We are filtering, or we were peaking, right? Peaking metrics, and this is such a dashboard, and it's showing like we have a tag with ABN AMRO. So you know we have 499 messages with that bank. We have something like Deutsche Bank was this one, and we have something with ING was this one. So you can think of your own metrics just to have it more visible. Hey, what is important, and what should I monitor? Exceptions, of course. If there are exceptions can be thrown, you show it also, so you can see it quickly instead of having difficult log statements, or you need to check log systems. They are mostly slow, and yeah, you don't want that. So that's that. Did everything 6? And you have Kafka Connect, and you can also do something with that, of course. Where's my... So, what you will learn. And this is for the special winners. I have here some stroopwafels for someone who says to me, for a consumer, we will use which annotation? The Kafka listener. For the producer, we're using Kafka template. And for the streams, we're using a streams builder. So I'm giving this for the next question. If someone has a question, is getting this. And yeah, so you can forget everything what I said, but listen to this. Use Kafka listener to consume messages, only 3 points. Use Kafka template to produce a message, and use the streams builder. Wisely, there's a DSL, right, with filter, map, and that. Go functional. And of course, again, tomorrow, if you go to a daily job, or next week, or next month, learn to create metrics so you can own your software with Actuator. That's also a nice tutorial. I have it here, and I will share it also. It's all about creating metrics. I think it's important. Everyone should do it. And you can watch it later. And I wish you a pleasant day at Jelly Nation, and thank you for joining. All my code is on GitHub, so it's here. Please follow me. And I want to thank you. Are there any questions? Yeah? Oh, wait, we have a mic. Yeah.
Okay, hello.
Yeah.
First of all, it was not clear to me. In your opinion, what's the advantage of using streams? When should we go for that option, and when avoid it?
Yeah.
If there is any case, we should avoid it.
Yeah, of course. Yeah, everyone nowadays wanted to use Kafka. Yeah, it's nice, and don't use it if it's just a simple thing, right? If it's really simple, don't use Kafka, I would say. But if you have a big data, like you have you providing millions or a lot of messages, that's big data, then use Kafka, because then it's quicker and you have the most advantage of it. And if you have something like payments cannot be lost. So yeah, that's very important, right? So you need to think about it before you, yeah, if the system is down and your payments are lost, this is terrible, right? So we don't want that. So think about that, I would say, and yeah.
Okay, thank you.
You like stroopwafels?
Actually, I asked it, okay.
Yeah, and give it to someone.
It's not because of that.
Yeah, no, yeah, sure. Are there any other questions? Yeah, so, yeah? Oh, there, yeah.
Yeah, hello. So I have two questions. So
Yeah.
first, I'm new to Kafka, so probably these dumb questions. But first, how do you guarantee that a message is consumed exactly once? So in case of payments, that I don't have two consumers processing the same payment.
Yeah.
And how can we do retries if there is an exception?
Yeah, that's all possible. That's a different, I try to, don't say it, but yeah, you have all kind of annotations with retry. You have something like you can have a default exception handler you can use. And in what you said about exactly once, you have it in your property. I don't have it in the code, but you can, in your application.yaml, you can give certain properties, right? And one of them is, I don't know what the name is, but you can say that it's exactly once, or you have also different properties for that. So yeah, that's possible, but it's something, yeah, much bigger to explain than now here. So I wanted to keep it simple. And, yeah.
Okay, thank you.
Yeah, and if you want, I have also some delicious thing here. There was another question there, right? Yeah. Nice, I like these questions.
Hello, just a question. So regarding another library, which is Spring Cloud Streams, which also using Kafka, which gives you more abstraction. What is the, I'm not sure if you use it, but it gives an abstraction regarding Kafka streams. You can use both. Is there any best practices for using both or just using one? Is there?
Yeah, it depends on your solution indeed. Yeah, we are within our assignment we are using a separate implementation, so that's also possible. So you have a Confluent implementation, you have an actual implementation, you have another implementation. So yeah, I don't know which one is best then, or the one that you said. I don't know. I need to also search. Yeah. So any other? Yeah, sure. Questions? Is it still possible, right? Yeah. Okay.
Just to make sure I just have the
Okay. Nice.
Okay, thank you. More and more I feel that we are moving towards this philosophy of event-driven architecture. I wanted to know your opinion about, do you agree or do you disagree on considering the data that is on Kafka as the single truth, the single point of truth? As all the other systems actually would rely on the data that is on Kafka.
Yeah, I also wanted to show you something about, you can also join, you have also something like tables, like you have balances, and you can put it all in a topic and a table, and you can join it and you can fill it both, but yeah, I don't know.
Okay, it was more if you agree or disagree, if you discourage or not.
A single point, yeah, it's there, so it should be all there in Kafka. So if you push something, it should be there, because yeah, you have a sequence, right? And if you commit it there and it's pushed, it's saved into the log. So it's based on the system. It's saved there. So yeah, it should be there. Or you have some problems with your cluster. So yeah, it should be the truth. Yeah.
Okay, thank you very much.
Yeah.
Thank you.
Any other questions? Then I want to thank you and have a wonderful day. Last track, and thank you.
Okay. I think we're on. So hi, everyone. We're thrilled to be here at JNation. Yeah, maybe we can turn the volume a little bit down. No?
You don't like the voice, sound of your own voice?
Yeah, it's kind of like I'm echoing to myself. Anyways, it's great to be here. We're thrilled to talk to you about Jakarta EE. My name is Tanja Obradovic. I work as Jakarta EE Program Manager, and this is my distinguished colleague. Go ahead.
Yeah, my name is Ivar Grimstad. I'm Jakarta EE Developer Advocate. And these are not my slides. Oh, there are other slides. So these are our slides. Our talk is called Jakarta EE 10 and Beyond. So I'll let it over to you, Tanja. So EE, where do we go to find information about this?
Oh, well, you can only guess, right? Jakarta EE is jakarta.ee, but at the same time, I want to tell how did we get to Jakarta EE? So at some point, Java EE was with Oracle, and it was decided to for the whole set of specifications to be contributed to Eclipse Foundation. And that happened quite a while ago with Java EE 8, that was with Oracle infrastructure, and what was, I think, Glassfish 5.0. And you can see the gradual steps that we made from moving it to Eclipse Foundation infrastructure with Java EE 8, and then moving it to Jakarta EE 8 with Jakarta EE with a new process, new licensing, new logo, Java's namespace still, and then we moved to the next release, which was kind of the big one, Jakarta EE 9. And the 9 release had the new Jakarta namespace. It was running on Java SE 8. And after that, due to the demand from the developer community, we moved it to Java SE 11 to support Java SE 11. But the significant part of that release was the amount of compatible implementations that were available at the time of the release. So, you know, once we released Jakarta 9.1, we were really ready to start innovating, and we're thrilled to kind of give you a little hint that we're just about to release Jakarta EE 10 that is going to have some new specifications, even a new profile, and you know, some individual specifications, and we're expecting it very, very, very soon. I don't want to give the date. So, Ivar, do you want to?
So you mentioned specifications.
Yeah.
And maybe we should just tell everybody what we think of is an specification in this context.
Do you want me to cover that?
Yeah, sure, go ahead.
Okay, so specification is a set of these 3 artifacts. So, a specification document that describes what that specification is all about. It's the API that contains and starts coding for anyone who wants to implement the specification. And then the TCK that needs to be passed in order to verify that the code works. And actually, we need to have the compatible implementation that will prove that the code works by passing the TCKs. And all that together is defining a final specification.
And by TCK, of course, you mean technology
compatibility kit,
right. Which is a set of tests that just test that to verify that the implementation implements the specification.
Yep.
Yeah.
Thanks, Ivar. Do you want to? Oh.
Yeah. So let's.
Why don't you cover the
10?
Yeah,
you mentioned 10 is coming, and it's coming soon, and we were actually talking about end of June. So June 28th, I've heard, is a possible date. So let's see, we're getting there. And E10 is a huge release for us. All the as Tanja said, in 9 we just did the namespace change to have this kind of migration path to make it easy to migrate. But in 10, we're kind of letting loose every specification and the community to contribute. And all the blue boxes there are updated specifications. So this is the complete set of specifications for E10 with the versions numbers and everything. The .0 releases are the major updates. So they have potentially backwards compatibility breaking changes, or they're just upping the release number for marketing reasons or something. But they're removing things, so it's kind of getting a little bit lighter. There's a couple of specifications that are good as they are, so they're not updated right now. And there's one new one in the corner, and we'll get into details about these specifications as we go. So this is kind of the entire platform. If we kind of take away a couple of the specifications on the left side of the stage here that are more of the enterprisey kind of specifications, we're left with what we call the web profile. And the web profile has been with us since Java EE6. And these are specifications that are targeting more traditional web applications. And if we remove these kind of web-y sort of specifications and those that are like faces, servlets, and web UI stuff, we're left with a set of specifications that we are calling the core profile. And this is brand new for E10. We're introducing a new profile. And as you see this stack of specifications, they are targeting microservices or headless services. So with this, we're introducing a lighter version of Jakarta EE. What we're also doing in 10 is to raise the API level. So with EE8 and 9, we were compiling the APIs to Java SE8. Now we're compiling them to Java SE11. And that means you need a Java SE11 at least to run this stuff. But what we're doing is also we're making sure it's running with 11 and above.
So what exactly does that mean? What about 17, 19, and...
Yeah, because we're at 19 is coming out soon. And so, yes, you as an app developer can use Java SE17 with Jakarta E10. And you just have to make sure that the runtime you're using are compatible or are running or tested with 17. So the important thing here is that we're testing for 11 and 17.
Okay, so what are we going to talk about next? Do we want to go into each of the specifications and discuss separately each one of them?
Yeah, I think we should go through each and every one of them and explain everything in detail.
Except we will stay for another week here.
Yeah,
which wouldn't be that bad.
No, and we know there is a party afterwards. So what we want to do, and this is kind of a surprise to Tanya. She doesn't know about this. And what I want to do is I'm doing a randomizer here. So I'm saying spin the spec, and I'll just pick a random spec, and Tanya's going to explain it for us. So let's spin the wheel.
Okay, well, let's see how that goes.
Security.
Oh, no, I don't know anything about security. Okay, well, let me tell you this. First thing for all of you is to actually visit this website, jakarta.ee/specifications, and select, in this case, security, to check what's going on with the security specification. But from what we are having here, it's a major release. It's 3.0. It indicates it's a major release. And we're evolving. Well, we're having new features. It's a major release and involving some of the new APIs. So we added support for Open ID Connect, and to enable that, we had to do some other updates to authorization and authentication specifications as well.
Yes, because these authorization and authentication are kind of the lower level things that the implementers of the application servers are using to provide this functionality for us. So it's nothing that you as an application developer are really exposed very much to.
Yeah, and as we are pointing out, it's a basis for the future work on this spec as well. So more to come for sure.
Yeah. Ready for a new spin?
Do you want me to spin one for you now?
Yeah, sure, go ahead.
Okay, which one is it going to? Oh, wow.
Oh, RESTful Web Services.
Okay, well, let me start off and then you take over. So again, here is the website where you can find out more details about it. And by the version number, we're indicating this is not a major release, it's a minor release, and therefore we're maintaining the compatibility and respecting that.
Yeah. And the project team here had originally planned a 4.0 release where they were doing more breaking changes, but they decided to stay on this compatibility with this release.
Yeah, go for it.
Yeah, so what are they adding then?
So we're adding the support for multi-form, multi-part form data. And what else? Do
yeah,
you want to?
So that means you can actually upload files through the APIs.
Yep.
And you have been able to do that before using REST-easy or Jersey or some other implementation. But this actually means that you can do it in a portable way. So it will work on all implementations, and it's a standard way of doing it.
Okay, and Java Sc Bootstrap API.
Yeah. And I see you've put a demo on this one for me.
So I'm looking at you, Ivar.
So let's demo this. And what they've done here is to add a way of bootstrapping a Jakarta REST application from a main method without using an application server. So let's have a look at some code. I have an application here. I call it BootyDuke, and that's because it's Bootstrap, you know. So it is a standard RESTful web application. It has a endpoint saying just hello world. So it's super simple. It just has this class. But the interesting thing here is in the application class, the Jakarta REST configuration. Here's where I can do some stuff. I could do it in any main method in some class, but it makes sense to do it here, and I'll show you why. So what I can do here is I created I have to create a main method first. Let's do that. So I create a main method in my application configuration, and then I can do some set up some configuration. It wasn't that one, sorry. Demo. Let's say Bootstrap config. So what I'm doing here is that I create a scbootstrap.configuration, and I set some properties there. I set the bootstrap, the root path for my application, and I set the port number to 8081, and I just build this one. So it's a fluent API to create. I have more things I can do here to set properties, whatever my application requires. This is kind of a super simple example. Then I have to create the application, and that is just instantiate myself. So just create an app here. And the next thing I do is to start the thing. And what I do here is I call scbootstraps.start, and then I just say print this stuff to the console and run it until I press Control-C. And as you see, I have to add the interrupt exception to the main method. So that's all there is to it. You kind of can configure it as you want. I'm using the same application, and if you look in my POM file, this is actually not a WAR file. I can create it as a jar, and rather than having just the provided API for the RESTful web services, I also add a runtime. And in this case, I've added REST-easy. If I want to use Jersey, I can use kind of the same dependencies for Jersey, but I have to choose a runtime. And then the next thing I can do is to just compile it. Maven clean package. I'm not sure if they've put staging out in central yet, so I'll use the staging repository. So I just compiler clients. Oh, yeah, I didn't have that. I misspelled it. Yeah, I misspelled it. So it's staging. There you go. But it looks like it is in Maven Central, so it works fine. And then I can run this class BootyDuke, and I use the assembly plugin, so it's the with dependencies. I just run this. It's up and running on 8081. So let's have a look at it here. Spiff it up, and you can see it is. Isn't it running 8081? It should be. So it's fairly quick to start. It's up and running, and it does the job without an application server. So this was the application. I just print the message. It's the Duke screening class. I'm running on REST EC6, but you can use Jersey or something else as well.
Okay.
So let's spin a new one.
Yes. Let's see. What else do you get? Oh my goodness, the persistence. So another one, minor release, right? Adding new features, evolving API, you know, where to look for the details. And I think what we added is universally unique identifier, right?
Yeah.
Do you want to move on? Yeah, as a basic Java type.
Yeah. So this actually means then that I can use UIDs as primary key if I wanted to. Yeah. So whether that's a good idea or not, that's up to you to decide. But at least there is support for it in the specification. Yeah. They've also added more things, but this is kind of the thing that fits on the slide.
So let's see what else we have.
Yeah.
Oh, CDI Lite.
Oh, that's an interesting one. I think you'll get that one.
So it is the major spec for the core profile that Ivar has mentioned earlier. And it is designed to work in the environments that are requiring new modern application development tailored to the web services and smaller runtime. So Ivar, why don't you give a little bit more details? How is that related to Graal VM? What exactly does it mean, dynamic at build time?
Yeah.
And
so,
all other details.
Yeah. So they in order to be able to compile to native using Graal VM, we need to kind of resolve all the dynamic features of CDI at build time rather than at runtime. And the portable extensions that are in CDI today are very runtime. Everything is happening when the server or application starts. So what they want to do is to kind of mimic these dynamic features at build time. So they've created a brand new extensions API called build compatible extensions that will enable you to do more or less the same thing as you can do in a portable extension, but do it at build time. So you can compile to native. I'll do a demo of this later. The demo here is for the backwards incompatible thing they're introducing now, and that's the empty beans XML. So we're changing the behavior of an empty beans XML. So if you're depending on an empty beans XML, meaning everything is injectable, then you may have to add an empty beans XML to specify it, or if you're using the annotated version today, you can actually remove the beans XML and have the same behavior. So maybe we should look at that.
Yeah.
And
why not?
Yeah. And to make it a little bit exciting here, what I'm going to do is I'm going to take this BootyDuke application and take that one and just drop it into a runtime and see if it works, because in this case, I'm not using CDI at all. So what I'll do, I'll leave the main method here. It doesn't do any harm. But the thing I'm going to change is, in my POM file, I'll just get rid of the terminal here. So in my POM file, I'll change this to be a war. And what I also want to do is to add the web API dependency here. So I'll Jakarta web API, Jakarta platform, and let's use 10. And I can also then actually remove all this stuff because I'm going to deploy into an application server, so I don't need any of this. So the POM file gets much simpler. I've now created a WAR file. I'll just reload this one. And then I'll deploy this one into GlassFist 7 and just see if it works. So let's take Bootyduke. And this one is kind of weird because when I do this demo, it sometimes works and it sometimes doesn't. So let's see. That's kind of the demo kind of thing. I hope actually it doesn't work, and it doesn't. You can see it didn't deploy. And why didn't it deploy? It says in the log file here that couldn't start it because somewhere it says CDI is not enabled. And this is kind of the thing. This would have worked with E9 because everything is injectable since beans XML mean all. So what I can do here, I can add an empty beans XML and specify it to all, or I can actually take this resource class and add a request scope to it. So it's kind of, now it's annotated. So now CDI will be enabled and discover it. So if I now do a redeploy here, you see it's green and it works. So now I can go to this one, and this one I'm running on 8080, so I just change the port number to 8080, and oh, sorry. It's just close 8080 Bootyduke hello, and it says hello, and it works. So this is kind of the place where you have to be aware of the breaking changes of CDI.
So
a new one.
Let's do it.
Oh, that's a big one.
That's a big one.
This is actually the core profile.
Yeah. So as mentioned earlier, targeting smaller runtimes, and I think there are. Do you want to go straight to a demo? Well, except
we can just repeat the specs.
Yes.
Yeah. So these are the specs that are in core profile, just to remind everybody. And what are we meaning with smaller runtimes? So with this, this is just possible. This is just me speculating. What we know is that Wildfly is going to be the compatible implementation we use to ratify this spec, so they will support core profile. What we hope is that Helidon, Quarkus, Micronaut, and others, also Payara Micro, for example, and all of the other sort of smaller runtimes, those that are already today providing some sort of compilation to native and run native code will also be implementing core profile. And I have heard rumors that at least Helidon and Quarkus are going to do it, maybe later this year, maybe next year.
Yep.
So do we want to do a demo of core profile? This is a very short and simple demo, or I'm not sure if this is the bigger demo. I can't remember really more. We messed around with the slides. So yeah, so this is kind of a recap. What I usually do in these demos is I take Jakarta E8 and I do the namespace change and everything over to Jakarta E9. What I'm going to assume here is that everybody have done this already, and we are on 9. So I'll just take it and go through it, what you have to do if you haven't done it yet. And there are several ways you can do it. One is transformation. So we have these tools called the Eclipse Transformer, and we have an Apache Tomcat migration tool that takes your bytecode and transforms it from the Java X namespace to the Jakarta namespace for you. So you don't have to do anything. You just run the tool on your deployable WAR file, and you can deploy it into an E9 server. It's super simple. There are also some of the servers have these tools built in, so you can actually deploy a Java X-based application into a Jakarta E9 runtime. But there are other ways as well. IDEs support it, and IntelliJ, for example, has this kind of migration step in the refactoring menu where you can migrate from Java EE to Jakarta EE. It's actually from Jakarta EE 8 to Jakarta EE 9, but it will also migrate a Java EE 8 application. And it will do everything for you with within your code base. And it will also make sure that you don't migrate the classes that aren't under Jakarta EE, such as JavaX, SQL, etc. You can also do it manually. And if you take a look at my GitHub, the Jakarta EE Duke application, there is a small tutorial there. You can do it step by step and go through and actually do this migration yourself. And it will take the entire application and do everything you have to do and actually do all these 6 steps. Not every application have all these 6 steps, but usually 1 and 2 you have to fix the imports when you do the POM update from the version 8 to 9. And then if you're using XML schema namespaces, you have to change these as well to the newer ones. And maybe some property files, bootstrapping files, and if you have some dynamic content that requires updates.
But I guess it is important to point out that those are all the steps that you may need to do for the full-blown application, not just a simple demo one. So yeah, it's a good slide to have handy if you attempt to. Hopefully you will migrate to Jakarta namespace, and you will need that slide to help you out.
Yeah. So what we're going to do then is take a simple application, upgrade from 9 to 10. That's a fairly quick step. And I'll also demo quickly core profile in Wildfly. And the application I'm going to use for the first step is my simple Hello World application, where I'm storing the message in the database. I'm using Jakarta persistence to retrieve the message. I'm having Jakarta enterprise beans to do my business logic around the message. And I'm using Jakarta REST to produce an endpoint that uses Jakarta JSON binding to serialize the output to JSON. And also have a CDI extensions that prints a log message to the console. When I move this to core profile, I have to switch this Dux extension to a build compatible extension. I'm not going to do all these steps here today. I'm just going to show the code how it is. Looks like. So if I want to change from 8 to 9, I'll use the complete Duke application. So this one has everything that I just showed you: the Duke's reading, the business logic in enterprise bean, and etc. So if I want to do this change from 9 to 10, it's very simple actually. What I do is I change the version number. So it's not harder than that. They're done. So I've upgraded, and since I'm not using anything that is backwards incompatible, I don't have to do anything else than just deploy it into a year 10 server. So that path is very simple. I can just drop it into Glassfish just to ensure you that it's still running. So complete Duke, I'll just add it there and deploy it. There you go. So it should deploy fairly quickly. I hope this wasn't my message, but let's see if it's here. So the Glassfish is running, localhost, complete Duke, and it says, how did Jakarta EE? And it sent 901, and that's the dynamic thing. I haven't updated it, the database. So if I wanted to print Jakarta 10, I would have to update my database from 901 to 10. One thing you can notice here is it says get date and get greeting, and that doesn't look very nice in the JSON. So there is a hack around this. And this is because I'm using Java 17 here. So I'm using 17. And what I also is using is a record to send out to the from my resource. So I'm returning a record there. And my entire business logic is to take the entity I find, the first entity I find in the database, and just map it to this record. So this is kind of my business logic. And the reason why I have this get, why I called this attribute get, this is kind of the hack to get older versions of JSON binding to actually discover a record. Otherwise, it wouldn't print anything because it expects a Java bean, which has a getter. But the good news is that the new version of JSON binding actually supports this, even though I don't think they intended to do it, but it just happens to work. So if I redeploy this one, it will display the message more properly in JSON. So we can kind of get rid of this hack you had to do in EU9. The other thing I wanted to show is a core application. So I have core Duke here, and before we do that, I'll go in here and look at the old CDI extension, the portable extension, and this is the way you would do that. You would implement an extension class, the service provider interface for CDI, and then you could observe things here. So I can look at classes with the at Duke's annotation and print stuff from it. And if I the Duke's resource here is annotated with @Dukes and says hi there. If I wanted to do this in a build compatible way, first I'll just show the POM file. I'm using Core API here, and I'm also using Java 17. And my application here is exactly the same, just I don't have the database thing. That's not covered by core profile. So my service here is just returning this record. And here you can see I have updated it, so it just uses the greeting like this. But the thing that differs here is the extension class. And what they've added is you now implement a build-compatible extension. So rather than implementing an extension, you implement a build-compatible extension. You also have to update the bootstrapping file from a file called inject SPI extension to something compatible SPI extension. And you don't have to remember this because this is the fully qualified class path for this interface. And here you can see it's an annotation-based way. So I have these different cycles, like at discovery, at enhancement, and etc. So you have to kind of just figure out which life cycle is that you want to hook into. And here I'm using the enhancement. And I'm just looking for annotations with the Dukes class and doing exactly the same printout. So if I drop this into Wildfly here, I'll just redeploy it. We should be able to see in the log file that it prints this. I found this Dukes annotation, and the message is high there. And it, if you look at the here, it's called core Duke, and it says low. So it works exactly the same way as it would you would expect. The difference here is the build compatible extension that I have available in the core profile.
And now? So this is about 10, right? And we want to invite you to start thinking about what's going on beyond 10 release. And there are some good indications that community is already excited about what's coming next. And we will go and just run through some of the new specifications that are on the horizon and some of the proposals as well. And of course, invite you to participate and start adding your wish list and contributing maybe to the existing proposals.
Yeah, so this is on a very early stage, and beyond 10 is 11. So usually, and
well, who knows? Maybe there will be 10.1.
Yeah, it could be a 10.1. You never know. We have done that before. We did 9.1. So yeah. So we're starting that work now, and this is purely speculation. And I would be very surprised if this actually happened, that we raised the API level to 17, at least on the platform level. I think we would see a situation where we allow it to be done on the individual specifications. But we must make sure that we can run on newer platforms. So whatever long-term support release that is the latest when we release this, and most likely that would be 21,
yep.
then we should make sure that the TCK runs on 21. So that's kind of the important thing. We need to make sure that we can run on newer versions, but we also need to kind of maintain a backwards compatible way for app developers to use the previous versions and get here without forcing them to upgrade too fast.
Okay, and so here are some specs that I mentioned earlier. So Jakarta config, that's in works. Please jump on, read about it, tell us what you need from configuration spec to support. I don't think I want to spend much time on...
No, config is very much in good state. They have weekly meetings. So every Tuesday at, I think it's 11 Eastern, or 10 Eastern even. Yeah, because 11 is the platform.
It's 10.
So 10 Eastern time, they have a weekly call where they discuss Jakarta config. And as you would probably guess, it's very similar to microprofile config. It will provide the exact same features as microprofile config does today. It will provide a migration path, and it will also add the things that are more kind of useful in a Jakarta environment, and remove some of the things that weren't that much used. So it's kind of the version 2.0, even though it would be a version 1.0 of Jakarta config.
And since you're mentioning the meetings, I just want to say that at jakarta.ee/connect link, you can find all the ways to get in touch, including the calendar where all the public meetings are published. So you're more than welcome to join any of the meetings and start listening in, and eventually working with the best of the breed in the enterprise world.
And how it most likely would look like something like this. You inject a property. This is using the CDI. It will also be a programmatic interface, and they will add a tree structure to the configuration properties. And I think they also think about doing meta properties, so you can define how properties should be defined. So it will be very advanced, but still simple to use.
Oh, this is right up your alley, Ivar.
Yeah,
So
this is my specification. So yeah, so I've been doing this for a long time. So we're standardizing the action-based model view controller pattern. And it's a standalone specification. It's a version 2.0 now. We're going to release a 2.1 that supports Jakarta 10. It's not a part of the platform. And I don't know if it will be a part of the platform ever, or if it will be a part of something in 11, maybe. If you want it, try it out, test it. It runs on most of the application servers available out there. And so try it out and provide feedback. And if this is something that is useful for you, let us know so we can make it to the platform. Because server-side rendering is coming back. So, and this is the way you do it. It's built on Jakarta REST. So you do it exactly as you would do with a RESTful endpoint. You just have the as control orientation. And we also provide different ways of defining the views. It could be an annotation like this, or you can return it. So it's very flexible, simple API.
okay, well, I'm not sure Ottavio is here, but this is something that he would be very proud of. So Jakarta NoSQL, supporting integration with NoSQL databases. Again, the link, there is a lot of work happening already for quite some time, so it will be interesting to see how this one evolves and where we go with it in maybe version 10 or independently. Like each of these specifications, I think that's important to note as well, is available on their own, regardless of whether they're part of the platform or profile.
Yeah, and NoSQL has released a couple of betas, so they are at beta 4 now.
Yeah.
And they are kind of waiting to release a final version until they have Jakarta config available, because they want to use that.
Yeah. RPC, it's a Jakarta RPC, I should say. It is brand new. It's just working towards establishing itself. So if you're interested in remote procedure calls, jump on and start working towards it. I believe, I'm not sure they have regular meetings yet, but
no,
that is
this project has been created.
Yeah.
It's up and running. It has a committer base,
Yep.
but they haven't really showed anything yet. So this is the time where you can jump in on mailing list and just ask, hey, what's going on?
Yeah.
And somebody will ask, and we can get it going fairly quickly.
And while we're here and not mentioning the meeting, each of the projects have their own mailing list. So if you are interested, please, through the website, it will be easy to navigate and find it out. And if not, you know where to find me, you know where to find Ivar, and we'll help you out.
Yes. So this is just a proposal going on, and we're not creating a new Jakarta Commons or because if you remember Jakarta Commons at Apache, we're not doing some utility that is going to be a super dependency for us. We just want to have a shared space where we can define some common things. Maybe this is where the Jakarta annotation specification comes out of, because that's common for everybody. So we're kind of looking at, it may not necessarily be a specification coming out of this. It may not necessarily be an API. It could just be some common ideas, thoughts. But this is a project proposal at the moment.
Yeah, and it's not up to us. It is up to the community to make a decision. So, again, invitation. Okay, and data access, Jakarta data, another proposal, very early stages.
This one is out for community review now.
Yeah.
So it's available, not on this URL actually, but if you search for new proposals at Eclipse Foundation, you can go in there and comment and see, is this the right way to go, or is it not the right way to go? And think Spring Data or Delta Spike data. That's kind of the thing we want to do, just in a standard way with Jakarta technologies.
Okay, well, let's just summarize everything for you. So the most important part, I guess, out of this talk is to remember that all the information can be found at jakarta.ee. And if you cannot find it from there, do let us know, because we want to fix that. So if something is to be taken away, please remember this. And then let's just move on to the great slide of 9.
Yeah, so we just wanted to recap what 9 is about before we also talk about 10. And this was to lower the entry barriers, to make it possible for new players on the market to create an application server. We removed a bunch of optional features and made a lot of things optional, so you don't have to implement it. We also wanted to
May I add just on that? If you go and look at the compatible implementations for any of our versions, we're extremely proud to see how many compatible implementations we have, and some of the new players are emerging as well. So it is really exciting to see the uptake. So yay for lowering entry barriers. It does work.
Yeah. And we also wanted to establish Jakarta as a platform for innovation. And I think with remember the slides of all the specifications in 10 and the work going on there, I think we've succeeded in that as well. And the last step is to make the migration easy. And the migration we're talking about is, of course, the JavaX to Jakarta namespace, which has sort of disrupted the entire industry. And people are working on it everywhere. And Spring 6, Spring Boot 3 will come out later this year, and they have done this conversion internally in their API. So you probably will be exposed to some of it. So even if you're using Spring, you will probably have some user story in your issue log to do this migration thing. So Jakarta 10, yeah. A lot of updates.
This is a lot of updates, a lot of work. Community is really coming together. We're extremely excited to see what's going on. And yeah, looking forward to what's coming next.
Yeah, and actually, I have brand new update. We had the platform call just a couple of hours ago, and manage beans here. We're going to deprecate it. So for 11, that will be gone, most likely. So we're deprecating it for 10, probably removing it in 11. The new thing we did in 10 was to introduce the core profile, and we hope to see many implementations there. The Java SE version was raised from 8 to 11, and we're making sure it runs on 17. We're testing everything on 11 and 17. We don't do the things in between, but if somebody wants to certify their server on 16, please go ahead. We don't have any opinion about it at all. We just chose these versions 11 and 17. And some resources.
And I think that's, again, the most important link and some of the other links that you may find useful. There are Ivar's weekly hashtag blogs that will give you fabulous idea of what's going on. There are monthly or bi-monthly updates from me as well on jakartablogs.ee. So, you know.
Yeah, and the Jakarta blogs, if you write something related to Jakarta EE or Java, you can get your blog listed there as well. It's an aggregator, so it's an instruction there to easily go in and add the RSS feed from your blog, and it will appear on Jakarta blogs.
And if you have an application that is using Java EE and you're moving to Jakarta EE, I would love to talk to you, and I would like to write about it and showcase how you do it, what are the challenges, hopefully none, you know, showcase to the rest of the world. So get in touch.
Yeah. Thank you very much.
Thank you.
First one who asks a question other than, can I have this t-shirt, gets this t-shirt. Any questions? It's a nice t-shirt. Yes?
What you just said. For example, I maintain a very old, I don't like to use this word, but okay, it's a very old Java EE-based application, Java EE7. And what you guys would advise as the first step, because there is no from zero to hero, I know this. This application is very complicated, let's say. I need to respect that. It's a legacy system, so on and so forth. Everyone here knows what I'm talking about. But if I would try to, I don't know, start a proof of concept, would you guys, what do you guys recommend first? I don't know.
So I would say it depends on what platform are you using, right? So are you using any application server? Or?
Yeah, Glassfish 5.
Yeah.
5.1.8.3, if I remember correct.
Yeah.
Yeah.
That's fine. So
that's my baby.
yeah. And depends on what type of application it is, right? So maybe slim down for the proof of concept, as you were saying. And if you remember that first slide that I showed, you have quite a few steps to select the appropriate Glassfish version to run it on, and then decide how you envision your application in the future, whether you want to just do the same application, do you want to do, so this is after proof of concept, like the mini one, try on that. I think it was Glassfish 6 or I can't remember, but one of the versions that supports Jakarta E9 with the namespace change. try to do a little one there for the proof of concept, and then depending where you want to move, like if you want to change your application, re-architect, or you want to keep it as monolith and change it that way. Ivar, do you have more advices?
Yeah, sure. What you could do is take your deployable WAR file, run it through the Eclipse transformer or the Apache migration tool, and drop it into Glassfish sticks and see if it works.
See how it goes.
Yeah.
Yeah. I do agree, because we are not only talking about the technology itself, but also maybe it's an opportunity to rethink about the architecture, and there's a lot of stuff to cover at
Moving
the same
parts.
time. I don't know.
This is a well-deserved T-shirt,
Yeah, oh yes.
I would say.
So thank you very much for listening, and we don't have time for more questions, but we have stickers there, so if you want to have Jakarta stickers, come up here and you get your T-shirt.
Yeah.
Thank you.